Let us now discuss sample problem number 2. A tied column 450 by 450 mm has an unbraced length of 5.32 meter. So we have a value of your concrete strength, which is equal to 27.6 megapascal. The yield strength of our steel, which is equal to 414.7 megapascal. A first-order analysis has resulted in the following axial loads and moments. So, meron tayong first-order analysis. So, yung PU natin, that is equal to 2,675 kN. Yung M sub 2 NS natin, so which is, kapag meron tayong subscript na NS, so meaning to say, no side sway tayo. So we have a 176.8 kilonewton meter factored end moment which causes no side swing. Kapag meron naman tayong subscript na S, meaning to say, with side sway tayo na merong value no 163 kilonewton meter. And of course, yung summation ng mga factored axial loads natin sa lahat ng columns on the floor, so we have 71,400 kilonewton. Doon naman sa critical loads natin, yung summation ng lahat ng critical loads natin sa columns sa buong floor, so we have 214,000 kilonewton. So we have an effective length factor na 1.3 which is denoted by K. So tinatanong dito sa problem natin, what will be the value of your magnified moment? O yung M sub C natin and the value of your eccentricity. So, to compute for that, siyempre, tingnan muna natin kung may effect ba yung slenderness ratio natin o yung slenderness natin dun sa column natin in computing for the value of your slenderness ratio. So, for columns, so since wala namang sinabi dito sa problem natin, kung brace by, wala namang sinabi sa column natin kung brace by yung column natin or hindi. So we can say na not brace yung column natin sa side swing against side swing. So meaning to say, kung wala tayong bracing against side swing, so ito yung gagamitin natin. I-compare natin yung slenderness ratio to the value ng 22. Kapag nag-less than yung value ng slenderness ratio natin sa 22, meaning to say, short column tayo, walang effect yung slenderness natin. So yung K natin, that is 1.3. Yung LU natin, that is equal to yung unbraced length natin na 5,340 mm over yung R natin, since meron tayong square column, that is 0.3 H. So yung H natin dito, that is 450. So we have a value of 51.42, which is greater than 22. Therefore, slender or long column. So after we know na meron palang effect yung slenderness natin dun sa column natin, we can now solve for the value of your magnified moment muna. So in computing for your moment magnifier, which is denoted by this symbol, so para makuha natin yan, yung formula natin that will be, so diba kung matatandaan natin, para makuha natin yan, in computing for the value of your M sub C o yung magnified moment natin, so that is equal to yung M2 NS plus yung magnification factor natin multiply by M2S. So for this one, meron na tayong given ng M2 sub NS at saka ng M sub 2S. So, ito na lang yung problema natin, yung magnification factor. And what will be yung formula natin for that? So, yung magnification factor, that is equal to 1 over 1 minus summation of PU over 0.75 summation of P sub C. So according to code, that must be greater than 1.0. So you have 1 over 1 minus summation of PU. That is 71,400 over 0.75. So dito kahit na hindi mo na kahit na hindi mo na i-convert yung kilonewton into newton kasi magka-cancel out lang yung unit natin. 0.75 multiplied by 214,000. So you will have a value of your magnification factor which is equal to 1.18. Greater than 1.0, therefore okay. So after we compute for the value of your modification factor, let us now compute for the value of your magnified moment. So yung M sub 2 and S natin na no side sway, that is 176.8 kilonewton plus yung magnification factor natin na 1.80 multiply by yung M sub 2 natin na side swing, which is equal to 163 kilonewton. So you have a magnified moment which is equal to 470.20 kilonewton meter. So this will be our answer. And of course, so ito yung design magnified moment natin. So in computing for the value of your eccentricity, so para makuha natin yan yung design magnified moment natin, that would be yung factored axial load natin multiplied by yung eccentricity natin. So we have a value of 470.20 is equals to yung PU natin, that is equal to 2,675 kilonewton multiplied by E. So the value of your eccentricity is now equal to 175.77, or that is approximately equal to 176 mm. So this will be your answer. So ganun lang kasimple yung slenderness natin sa column.